Welcome dear students. So today we are going to start a new chapter and the chapter number is chapter 7 and the name of the chapter is Indices. Okay, so since you have seen this chapter in your class set as well, my work is going to be a bit simpler. Okay, so you have come across all these formulae in your class 8 only. Okay, so let's see the few problems which we have already seen in our class 8 also. Okay, so we have got the first problem on the screen. You need to evaluate this. Okay, so if you remember, I had said that you have to look for the smallest base here. And here we have got 3, 243 and 9. So these three are the different bases out here, isn't it? So here we see that the smallest one is 3. So whatever bigger ones are there, we will first factorize them. Okay, so we have got, this is your question, so let's factorize. So when you factorize 243, you will get 3 into 3 into 3 into 3 into 3. So altogether there are 5 3's. Okay, so in the same way, we have got 9 here and this 9 can be written as 3 into 3. Okay, so what is this actually? 3 into 3 into 3 into 3 into 3 is 3 to the power 5. Okay, and similarly 3 into 3 is 3 square, right? Okay, now we have got the laws of exponents written here, isn't it? So let's compare these two with any of these laws. Now look at law number 3, which says a to the power m whole to the power n is a to the power mn. That means you are multiplying the powers, isn't it? So here also we have got the same thing. So here also we will multiply the powers. Okay. So when you multiply, you get 5 into minus 2 by 3. So you know that you will multiply only the numerators. So you get minus 10 by 3. And similarly here, when you multiply, you get minus 2 by 3. Please make a small correction out here. This is not 1 by 3. This is minus 1 by 3. Okay. Fine. So we see that in this line we can make use of the first law, isn't it? Because we see the bases are same. So whenever the bases are same, we have to add the powers when you multiply such kind of numbers. Okay. So when you add the powers, you will get this much. So this is just addition or subtraction of fractions. Yes, so find the LCM and simplify it. You get this to be, in the power you get minus 3 by 3 and after cancellation you get 3 to the power minus 1. Now look at this law. If I apply this law in this, you will get 1 by 3. So this is your answer for this particular question. So you may pause the video and note down the solution. So let's have another problem here. So I'm taking number 2 for you. So the question says we have to evaluate this particular expression. Okay, so first we'll deal with 25 and 5. Now you know that this 25 can be written as 5 square, isn't it? So that's why instead of 25 I've written 5 square here, and in this case this is 5 to the power minus 3, isn't it? Here I have made use of law number 5. Okay, so this law is used here and that's why I have written here 1 by 5 cube. Okay, now again I'm going to use the second law here. Okay, so let's apply the second law. I'm sorry, this is my third law in this case. Okay, so you know that the powers will get multiplied, isn't it? Okay, so this 2 and 2 gets cancelled. So you get again 5 to the power minus 3. Okay, and all of you know that 7 to the power 0. Okay, if I use property number 4, you know that this 7 to the power 0 is 1, isn't it? So we have 7 to the power 0 is 1, and how much is this actually? This is again using this particular law, you will get this to be 1 by 5 cube. Now since both of them are same, they will get cancelled with each other and you will get your answer to be 0. Okay, so you may pause the video and note down the solution. Let's have this problem now. Here again, you have got 16 and 81. You know that they can be factorized. Similarly, this 49 and 9 can be factorized. Similarly, you have 343 and 216. They also can be factorized. So let's factorize each of them. So when you factorize 16, you get 2 into 2 into 2 into 2, and factorizing 81 will give you 3 into 3 into 3 into 3. Similarly, 49 can be written as 7 into 7, and 9 can be written as 3 into 3. Okay, factorize 343, you will get 7 into 7 into 7. And similarly, this 216 can be written as 6 into 6 into 6. Okay, so altogether we can express the same expression in this way. Okay, now let's apply law number 3, where you need to multiply the powers. Okay, so when you multiply the powers, you see that the numerator and denominator are getting cancelled. Okay, so these two gets cancelled and you get minus 3 here. Here also 2 and 2 gets cancelled, you get 3, and here also 3 and 3 gets cancelled and you get 2. Okay, so I don't have space here. You may pause the video and note down till here. Okay, so we were stuck here, isn't it? Okay, now let's apply some other laws here. Here in this, I'm applying law number 5. Okay, because we have got a negative sign in the power. Okay, and here this division is written multiplication. Okay, and whenever you do that, you know that this will get upside down. Okay, so in this case, these two can be written in this way, isn't it? So 2 by 3 cube means 2 by 3 into 2 by 3 into 2 by 3, and 7 by 3 cube means 7 by 3 into 7 by 3 into 7 by 3, and 7 by 6 square means 7 by 6 into 7 by 6. Okay, so when you simplify this, you will get this much. Okay, so you may pause the video and note down the solution. So I'm taking now question number 2, sub number 1. So here the question says simplify this particular expression. Okay, now this division can be written in this way also, isn't it? And we have got 8x cube, and when you factorize 8x cube, you get 2x into 2x into 2x. And similarly, when you factorize 125y cube, you get 5y, 5y and 5y. Okay, and outside you see the power is 2 by 3. Now can I write this inner expression in this way? Yes, definitely, yes. Okay, now here again I'm going to apply law number 3, which says multiply the power, and when you multiply the power, 3 and 3 gets cancelled and you get this much. Now this means what? This is 2 square, which is 4, and x square is x square itself, and similarly 5 square is 25 and y square is y square itself. So that's why your answer will be 4x square by 25 y square for this case. So you may pause the video and note down the solution. Okay, let's have a look at this now. So this is actually a very simple problem. Only thing is you need to be very careful with the formula. Okay, so we have got this. Now can I apply formula number 5 here? Because you see that there is a negative sign in the power. So if you do that, for the first one you get 1 by a plus b, and similarly this means into, right? So a to the power minus 1 can be written as 1 by a, plus b to the power minus 1 can be written as 1 by b. Now all of you know that as per your board mass rule, we need to first simplify whatever is there within the bracket. Okay, so let's simplify. So in order to simplify this, you need to find the LCM of the denominator, divide the LCM by the denominator, how much ever you get. For example, here AB when divided by A, you get B. So B into 1 is B, plus divide this LCM by B, you get A. Okay, B and B gets cancelled and you will get A. So A into 1 is A. Now, can I write this B plus A as A plus B? Yes, we can write this. Now, you see that a plus b and a plus b, they get cancelled. So that's why ultimately you are left only with 1 by ab. Okay, so you may pause the video and note down the solution. Okay, so let's have a look at the last question for the day, which says simplify this particular expression. Okay, so here what we are going to do is we will separate this. Okay, so you have n plus 3 in the power. So can I write this as 5 to the power n plus 1 into 5 to the power 2? Yes, because as per your first law of exponent, we can separate the powers. Okay, so m plus n can be written as a to the power m into a to the power n. That's what I have done here. Okay, ultimately when you add the power, you will get n plus 1 plus 2, which is again n plus 3, isn't it? Okay, so similarly we have 5 to the power n plus 1 and 5 to the power n plus 1 here as well, which can be taken as common. Okay, so whenever you take 5 to the power n plus 1 outside, here you have 5 squared and here you have minus 6. Okay, and in the denominator also you have 5 to the power n common, and when you take out 5 to the power n common, you have 9 here, and here you have got 2 squared, which is nothing but 4. Okay, now this 5 squared is how much? It is 25. So you see that 25 minus 16 is how much? It is, I'm sorry, 25 minus 6 is 19. Okay, and here we have 5 to the power n into 5, and this 5 is actually 5 to the power 1. Okay, now again apply the first law. Okay, so when you apply the first law, you see that the powers will get added and you will get 5 to the power n plus 1. In the numerator also we have got 5 to the power n plus 1, and in the denominator also we have got the same. They will get cancelled. So ultimately how much is left? Only 19 is left. So that's why when you simplify this particular expression, you will get your answer to be equal to 19. So you may pause the video and note down the solution. So your homework is on the screen. So kindly do the homework and send it to me. Thank you very much.